This is our fourth lecture, and in this lecture we are going to talk about powers and radicals. We are going to define and use the boundary, and we are going to compare a positive number to its square, reciprocal, and its radical, and we are going to differentiate the different types of intervals. Let us start first by ordering and comparing. You have to know that if I say that A is greater than B, then their subtraction is positive. And if I say that A is less than B, then their subtraction is definitely negative. But if they are equal, then their subtraction is going to be 0. But if they are not equal, then their subtraction is not 0. Now, what if I have inequalities? The first property says that if A, B, C, and D are real numbers, and if A is less than B and C is less than D, then if you add the boundaries here, A plus C is definitely going to be less than B plus D. Example, if I have 2 less than 5 and 3 less than 4, if I add 2 and 3, I'm going to get 5, which is less than 9. So their addition will never change their sign. The second property says, if I have A, B, C, and D are positive real numbers, then their product will never change the sign. So if I multiply the boundaries with each other, the sign will never change. I'm talking in this case about positive real numbers. Example, if I have 2 less than 5 and 3 less than 4, then their product, which is 6, will remain less than 20. Let us talk about some properties of inequalities. If A is greater than B and B is greater than C, then definitely A is greater than C. This is logic somehow. If I have A greater than B and I added the same number on both sides, this will never change their sign. And if I multiplied them by a positive number, it also will never change their sign. But if I multiply them with a negative number, the sign here in this case will be changed, because you know that positive numbers, for example 2 and 4, 2 is less than 4, but minus 2 is greater than minus 4. So yes, if you multiply them by a negative number, the sign will be changed. Now what if I did the reciprocal? So if I have A is greater than B, in this case 1 over A is less than 1 over B. So the sign will be changed. So till now we took that if I multiplied with a negative number, the sign will be changed. And if I did the reciprocal, the sign will be changed. Let us do some operations on the equality, which is the third property. If I have A greater than 1, then 1 over A is less than 1, is less than radical A, is less than A, is less than A squared. This in case A is greater than 1. But what if A is between 0 and 1? The equality will be changed. I will have A squared in this case less than A, less than radical A, and less than 1, which is also less than 1 over A. For example, if you have A equals to 4, then 1 over 4 is less than 1, is less than radical 4, is less than 4, is less than 4 squared. Now, example. Let us show that if 1 over radical 3 minus 1 is greater than 1, I have to show that 1 is less than radical 3 is less than 2. Let us take 1 less than radical 3 less than 2. I'm going to find radical 3 minus 1. So it's going to be 0. So I'm going to subtract 1 from the boundary. So I will get 0 less than radical 3 minus 1 less than 1. The second thing I'm going to do is to find the reciprocal, okay? So just do them step by step. So you will get 1 over radical 3 minus 1 greater than 1. So as I told you, if you are going to do the reciprocal, the sign will be changed. Now, what if I have A is less than B, A is positive, and B is positive? In this case, A over B is going to be less than 1. 1 over B is going to be less than 1 over A. The squaring of A is going to be less than the square of B. And radical A is going to be less than radical B. So, example, if A equals 3 and B equals 5, then 3 over 5 is less than 1. We are just applying directly the rules. 3 squared is going to be less than or equal 5 squared. Radical 3 is also less than radical 5. And 1 over 5 is less than or equal 1 over 3. But if both of them are negative, then everything will be changed. In this case, A over B is going to be greater than 1. 1 over B is less than 1 over A. The squaring also will change. And now we are going to learn how to graph the solutions to an equality. To graph any number greater than, you should put an open circle because this value is not included in my domain. If I have also less than, also it will be open. But if it's or equal, then this should be closed. Okay, the number should be closed. In this case, the number is excluded. In this case here, the number is included in our domain. Also less than or equal, it should be closed because I need this number. So, as an interval, the open interval means I don't need the extremities. They are excluded. As you see, both of them are open. In the closed interval, I should close the interval on the extremities because I have or equal. That means it's a closed because I need them. A and B are included in my domain. And open close, sometimes you might have an open in one extremity and closed in the other. So as you see, you sketch them in this way. You can draw a circle, open circle, and you can draw a dotted line. But in the case if it's closed, you can draw a complete line. The same thing for the closed open. It's the same thing. This is an important remark. If I have x is included between two positive numbers, the squaring will never make a change. The squaring of the first boundary will remain in its place also for the second boundary. But if I have both of them negative, they will be flipped. And if one of them is negative and the other is positive, I should write 0. So the negative number becomes 0 and the positive number stays as it is.